The machine learning pipeline involves a series of essential steps to put a model into operation, starting from the initial planning stage. It begins with defining the domain. In our case, this is technical analysis. Following this, relevant data like open, high, low, close prices, and volume is collected and preprocessed. This includes exploratory data analysis, feature engineering, and feature selection. Next, appropriate algorithms are chosen, and the model is trained using these algorithms. The training process involves tuning the model and iterating until satisfactory performance is achieved. Finally, the model is evaluated, and if it meets the desired criteria, it is deployed into production for making predictions. Let's say we want to determine if an image shows a cat or another animal. To create a cat recognizer, what do we need? Data on cats. However, our domain is technical analysis. If we can classify the charming whiskers as a cat or not a cat, can we also classify the expected direction of a breakout from a consolidation range as bullish or bearish? And to do that, what will we need? Same as with cats. We needed cats data, now we need data on consolidation ranges and its breakouts, whether in the form of images or data tables. And if we want to predict whether the SIP 500 will go up or down tomorrow, again, what we will need is historical data on the daily rises and falls of the SIP 500. The first thing we observe in the pipeline is the domain, which is the area concerning the problem we want to solve. In this case, we have turned to the classic example of recognizing whether an animal is a cat or not. To do this, it will be important to know what types of cats exist for training the model, such as for type, color, etc. Without understanding the domain, the problem might be poorly defined from the start. This is a common issue in the field of technical analysis, where many academic approaches try to solve unsolvable problems, perhaps due to a lack of deep knowledge in the domain of technical analysis. Once a problem is properly defined, we need data. In this example, it will be images of cats so that the model can learn what a cat is. The data processing involves several steps. 1. Exploratory data analysis, EDA. This step involves summarizing the main characteristics of the data, often using visual methods. It helps in understanding the patterns, spotting anomalies, and checking assumptions with the help of summary statistics and graphical representation. 2. Feature engineering. This is the process of using domain knowledge to create features, input variables, that help the machine learning model understand the data better. 3. Feature selection. This involves selecting the most important features from the dataset that have a significant impact on the prediction outcomes. This helps in reducing the complexity of the model and improving its performance. 4. Feature importance. This step evaluates the importance of each feature in making accurate predictions. It helps in understanding which features contribute the most to the model's decisions. All of this is used to feed the model. However, the model also requires appropriate algorithms for these data. Essentially, these are the formulas capable of statistically handling the data to make predictions. Since we want to classify between two possibilities, cat or not cat, we will employ classification algorithms. There are many different algorithms, each suitable for certain problems and types of data. With this, we can train the model. Training the model is a process where the algorithm learns from the data to make predictions. After training, we need to evaluate and tune the model. This involves testing the model's performance and making adjustments to improve its accuracy. If the results are not satisfactory, the process is repeated, changing data or algorithms and retraining until satisfactory results are achieved. Finally, we can develop and monitor the model, putting it into production to make predictions. This means providing it with images to decide whether or not they are cats. Similarly, if we focus on our domain, technical analysis, we can assume we want a model to predict the expected direction of a breakout from a lateral range. In this case, the data we work with will be a table of cases in which we have incorporated market data. The model will try to learn the possible patterns in this data to make accurate predictions. First, we will conduct exploratory data analysis, EDA, looking for anomalies, errors, inconsistencies, and also understanding the structure of the data we are working with, including their ranges or distribution. Next, we move to feature engineering, where, from the price data, we create a series of technical indicators like moving averages. Feature selection will help us choose the features, that is, the predictive data that we want to work with. In the feature importance step, we will evaluate the contribution of each feature to the model. We will select a classification algorithm appropriate for the problem at hand, and then train, evaluate, and deploy our model. With this model, we can make predictions about the direction of breakouts in future lateral ranges observed in the market. Lastly, to clarify the pipeline, suppose the problem at hand is predicting the direction of the advance or decline of the S&P 500 index tomorrow. In this case, we use images as data, so the algorithms will have to be deep learning algorithms, the only ones capable of working with images, as we will see later in the course. In the next video, we will discuss the difference between supervised and unsupervised learning.